So this is the first of several videos where we're going to talk about the importance of understanding the unit circle, not necessarily memorizing the unit circle, but understanding the unit circle. So I'm going to start off with angles that are at a 45-degree reference angle to the x-axis. So here, and here, and here, and here. Now, chances are most of you are comfortable with degree measurements, 45, and then another 45 degrees would be 90, and another 45 degrees would be 135, another 45 degrees would be 180. Of course, I think we all know that one at this point. Then we have 225, 270, 315. Of course, that's 0, and also 360. Squeeze it in there. Okay, so if I take each one of these triangles and I move them back to the x-axis, it forms a right triangle. So here's my first right triangle with a 45-degree angle. And again, here and here and here. So each of those are 45-degree triangles, 45, 45, 90, as a matter of fact, if we take them back to the x-axis. Now, the thing about this is a lot of people are confused by the radian measure. So let's talk about radians just for a second. If we are taking 180 degrees, which would be the entire upper portion of the circle, and we're cutting it into 4 equal parts, 180 divided by 4, 45 degrees. So it makes sense that if 180 in radians is the same as pi, that 45 degrees would be pi over 4. So it's not a mystery where this comes from. This is 1 pi over 4. This is 2 pi over 4, which is the same as pi over 2. This is 3 pi over 4. And this is 4 pi over 4, also known as pi. That makes this 5 pi over 4, 6 pi over 4, which reduces, 7 pi over 4, and 8 pi over 4, which is 2 pi, also 0 in radians. And so these measurements that you see on your unit circle might seem like they're a mystery when you're talking about the radian measure, but they actually make tons of sense. So the idea here is that everything on the unit circle that has a denominator of 4 is going to have the exact same ordered pair because they all refer to the exact same triangle, the 45, 45, 90. So if my radius here is 1 unit, then my sides would have to be take the hypotenuse and divide by the square root of 2. Because if we think to what the 45, 45, 90 triangle looks like, whatever the two legs are, we take that measurement and multiply by the square root of 2. So if we already know that this measurement is 1, then we would need to divide by the square root of 2. So here, excuse me, my side is square root of 2 over 2 and square root of 2 over 2. In this case, as I move to the left, that is negative square root of 2 over 2. This is positive square root of 2 over 2. Here, I'd be going left and down, so that's negative square root of 2 over 2. Here, I'm going positive square root of 2 over 2, and down, which is negative square root of 2 over 2. So you'll notice that these are all 45, 45, 90. The sides are all the same, but because we have it on a coordinate plane, some of the measurements are going to be negative depending on the direction that we're going. So when we're writing ordered pairs for each of these radian measures, when we're at 45 degrees, remember that our ordered pair is always cosine of the angle and then sine of the angle. So over here, the cosine and the sine are the same because the sides are the same. Cosine would be adjacent over hypotenuse, sine would be opposite over hypotenuse. So at pi over 4, the ordered pair is root 2 over 2, root 2 over 2. And honestly, they're all going to be that. The only difference is going to be whether we go negative or the measurement is positive in terms of relationship to the origin. So here at 3 pi over 4, we have to go left, then up, left, then up. Here, root 2 over 2, root 2 over 2. We're going left, then down, left, down. Here, root 2 over 2, root 2 over 2. We're going right, then down, right, down. And this is consistent with the quadrants. First quadrant, positive, positive. Second quadrant, negative, positive. Third quadrant, negative, negative. Fourth quadrant, positive, negative. And so that is the 45-degree angle on the unit circle with the ordered pairs in relationship to the 45, 45, 90 triangle. Next up, we're going to look at the 30, 60, 90 triangle.